Hey. Ian, Philip, Kane is here. Macho, Kramer, Karapinski, Joshua Lopez here, Brendan Lopez, Momberg is here. Martin, Reed is here. Retzlaff, Richie, and Yakashenko. All right, so chapter 5 is what we'll be discussing today. And chapter 5 deals with nomenclature, how we name compounds based on their formulas and vice versa, right? And I think in the videos I've posted, I think I went into a bit of history, not much, basically talking about the fact that in the olden days, people used to talk about, or name chemicals, I should say, based on the properties that they display. And while that is useful in some cases, it has its limitations in that if you're going to use that as a way of naming compounds, you won't know, for example, based on those names, the composition or the structure or whatever, right? So chemists have come up with rules concerning naming compounds, and I went into a couple of them for the more simpler compounds, binary compounds. Let me start with binary ionic compounds, binary metallic compounds, and then ionic compounds, and so on and so forth. So that's basically what we'll be doing today. We'll be looking at how we can follow the rules so that we can identify the formula for a compound based on its name and vice versa. So the first group of compounds I want to talk about are compounds known as binary ionic compounds. And basically, in the case of a binary ionic compounds, it's a combination of a metal and non-metal. Right? So there are two elements. One must be a metal and the other one must be a non-metal. And that will result in the formation of what is known as a binary compound. Now, when it comes to naming, right? These compounds, what we do is that we start off with the full name of the metal and then the stem of the name of the non-metal followed by IBE, right? So full name of metal and then the stem of the non-metal followed by IBE, all right? So a good example of this is sodium chloride. The formula is NaCl, and basically it's sodium, right? That's the first part here. And then chlor, which is the stem of the name of the element, which is chlorine. So we don't use the full name chlorine, and then we end it with IBE. So instead of chlorine, we say chloride, right? So the name of this compound would be sodium chloride, right? Here's another example. Suppose you're given, suppose you're given right, this formula here, Mg2s3, right? The name of this compound is magnesium, right? So the metal part. Oh, and by the way, the metal part will be first, right? Always. And then the non-metal part afterwards, right? So magnesium will be the first part of the name of this compound. And then this is sulfur here, right? So the name of the rest of the compound would be sulfide, right? Again, the IDE ending, just as in the case of sodium chloride, we have magnesium sulfide, right? So Another thing I need to point out here is that the names of all these binary ionic compounds must end with IDE in the second part of the name, right? All right? Another thing I want to mention too is that the name of the compounds would not include any indication as to the number of atoms involved, right? So like in this case here, it's a 1-to-1. You have one here and one here for the sodium and chloride respectively. But in the case of magnesium sulfide, you have a 2 here and a 3 here. The name, however, of the compound will not indicate the number of magnesium or sulfur that is indicated in the formula, all right? However, those numbers are important because they show the composition, right? And by now, I think you should know how to figure out what the formula is. So what I'm going to do is a couple of examples right now. Is it okay for me to delete this? All right, so let me delete this here. And I'm going to go into some examples. So let's say, for example, you're given let's say you're given calcium, whoops. Let's say you're given calcium phosphide. All right. So the first thing I would do is consult the tables. Now, I think I pointed out some tables that I've posted in Canvas, which you will have access to in your test. Let me see if I can bring that up. There are a list of ions. Tables. Okay, so this is one of them, which gives a list of common ions. This is another one, and then there's a third one. So you can consult these tables in order to answer questions like the one that we're doing now. So to answer this question, what I would do is consult the tables, and I would look up the formula for the calcium ion. And when I look it up, I'll see that the formula for the calcium ion is Ca2 plus, right? So the charge on the calcium ion is +2. And then I'll look up the formula for the phosphide ion, and when I do that, I see that the charge is 3 minus, right? So when it comes to determining the formula for an ionic compound, you have to ensure that the compound is neutral. And what that means is that the total number of plus charges must be equal to the total number of minus charges. As we have it right now, that's not the case. You have +2 here and -3. So the question is, how do we equalize the charges? And we do that by multiplying this by 3 and this by 2, right? Because 3 times +2 gives you what? +6. 2 times -3 gives you what? -6. So because you have the charges equal and opposite, then basically they will cancel out. So when you put this together, this is how you do it. Ca, this 3 here becomes a subscript, and then P, and then this 2 here becomes a subscript, and that would be the final answer, right? So that would be the formula for calcium phosphide. All right? Any questions? Any questions? So let's say I gave you, let's say I gave you potassium nitride. Okay, so how would you go about determining the formula for this? First thing you have to do is look up potassium. What's the charge on potassium? 1. +1, right? And what's the formula? I'm sorry, what's the charge on the nitride? Exactly. Okay, so we have +1 here, we have 3 minus here, so how do we equalize the charges? Exactly. So when you put this together, just like we did here, what will the final answer? K3. Exactly. That's it. All right. So that's how you determine the formula for binary ionic compounds based on the name. And you should be able to do the reverse. So for assignment number 5, we're going to start off with naming such compounds. You, and this is for you. And for those of you out there in Zoom, I'm going to publish this assignment right now. So assignment, oh, by the way, for those of you out there in Zoom, there are 2 links, right? I'm going to show you right now. Right, these 2 links here, that's basically assignment 5 combined, right? So make sure that you download both of them so that you can complete that. Now, let me help you out, or let me see if you can help yourselves out with the first couple of questions. Okay, so this is it right here. So the first question is, what's the formula for the compound that's formed between beryllium and fluorine, right? So, turn on my pen. Okay, so what would be the formula? How would you get the formula for the compound formed between beryllium and fluorine? So you have to look up beryllium, and what's the charge on the beryllium ion? Okay, so the formula for the beryllium ion is +2 or 2 plus, Be 2 plus. What about the fluoride ion? Okay, so F minus. So how do we get the charges neutralized? The 2 in front of the fluoride, right? So when you put this together, what's the final answer? Be, no, not 2F, F2. This 2 becomes the subscript right here, right? So that's the formula. What about the name? What's the name of this compound? Fluoride, exactly. Okay, so what I want you guys to do is to complete this table. And then I need to talk to you about some other stuff. Ready? Good. Part A, or almost finished. All right, so let's move on to part B. Now, part B is dealing with binary ionic compounds, but with a bit of a twist. And the twist is that there are certain metals, usually in the transition region of the periodic table, that can form different ions with different charges, right? So an example of that would be, an example of that would be there are two forms of copper ions, two types of copper ions. All right, so one of them would be one that carries a +1 charge, and the other one carries a +2 charge. So this provides a challenge because whenever you're naming compounds, each compound must have their own unique names, and that should include the type of ions and also include their charges, right? So according to, and by the way, there's an organization that is responsible for all the rules that we've been talking about. It's called IUPAC. Let me mention them first, and then I'll go into what I'm about to discuss. IUPAC, International Union of Pure and Applied Chemists. And there's a division of that group, that organization, that meets every so often. I don't remember, I think it was every 2 years or something like that. And their sole focus and purpose is to come up with rules because, you know, from time to time, new compounds would be made, for example, or discovered. And then the rules that are in place would not be able to cover those compounds. So they have to go back and make up rules for accommodating those compounds. So all these rules that we're talking about is due to IUPAC, right? So according to IUPAC, in order to distinguish between these two compounds, we call this one copper 1 in parentheses, Roman numerals in parentheses, and this one is copper 2, right? The system that is used in this case is called the stock system. I'm not sure why it's called that, but that's basically the system that is used. So basically, according to the stock system, whenever you have situations where a particular metal atom can form 2 or more different ions, you distinguish between them by writing their names and then putting in Roman numerals the charge that's associated with those ions. So in the case of Cu plus, that is called copper 1. In the case of Cu2 plus, that's called copper 2. Here's another example. Fe2 plus, Fe3 plus, right? This is called iron 2. And this is called iron 3. All right? So that's the stock system. Now there's another system, which is, to be perfectly honest, not as useful. It's called the classical system. And let me explain how that works. I'm going to use the same examples as before. So in the classical system, this is called cuprous ion. And this is called cupric, right? And then when it comes to Fe2 plus, Fe3 plus, this is called the ferrous ion, and this is called the ferric ion, right? Now, this one is not as useful because in this system, you cannot tell what the charge is based on the name, right? The only thing you can tell is that whatever ends with ic has one more charge compared to whatever ends with OUS, right? But it's not that useful, but that's an older system, which is still used in chemical literature today. The first one, the stock system that I talked about, is more useful because you can't tell what the charges are because we use Roman numerals to indicate the charge, all right? So with that said, let me go to the assignment. I know why I couldn't erase that. That was clear that. Okay. Let's scroll down. Okay, so in this case here, there are some of these which involves the type of ions I just mentioned. So let me start off with the first one here. So for the first one, the name of this compound is calcium chloride, exactly. All right, so that one is simple enough. But this one now you have to be careful about because iron, as we saw before, is one of those elements that can form different ions of different charges, right? So it's not enough for you to just say iron nitride in this case, because now you have to ask yourself, what type of iron is it? Is it +2 or is it +3, right? And the answer to that comes, let me do it over here. So this is Fe3N2. What this tells us is that there are 3 iron ions and 2 nitride ions. Now we know that nitride, if you go to the table, we know that nitride carries a -3 charge, which means that the total charge here will be -6. If the total charge carried by all the anions is -6, that means that the total charge here will be +6 for the iron, right? So if the total charge here is +6, then what does that mean for each iron? What is the charge for each ion in the case of iron? If 3 of them carries a +6 charge, then one of them will carry what? +2. So therefore, we have to put 2 in Roman numerals here. And that would be the correct name of that compound, iron 2 nitride. All right? And that's basically how you would determine. Now remember, we only indicate, I don't know if I said this before, so let me say it now. We only indicate in Roman numerals the charges if and only if the element can display more than one charge, right? So we would not use that in the case of the first one because calcium, only one charge associated with the calcium ion, and that's +2. But in the case of the iron, you have 2 possibilities. You have +2, +3. In that case, you must include in Roman numerals which one you're dealing with when you're writing down the name. So in this case, it would be iron 2. In the case of the next one, if you look up titanium, and remember, I think titanium can be +2 or +3, right? In this case here, because each bromide has a -1 charge, and there are 3 of them, right? That means that the titanium must have a +3 charge, right? So therefore, the name of this compound is titanium 3, oops, 3 bromide. Ah. All right, and that's basically what you need to do for the rest of this. Any questions? Any questions? Okay, let me clear this here and see what's below. Oh, and then this is the reverse. They give you a name and you're asked to write on the formula, which is actually easy, right? So right now I want you to work on part B, questions 1 through 20. Okay, are we finished with section D? Section D? Finished? Right, we're on section D. Then we move on to section, part C. So let's move on now to part C, which deals with a different type of compound. It's binary, but this time we're dealing with binary covalent compounds, right? So in the case of binary covalent compounds, these are compounds that are made up of two elements, and these elements are nonmetals, right? So that's the difference between binary covalent or molecular compounds and binary ionic compounds, which have a combination of a metal and nonmetal, right? So basically, we're dealing with two metals or two nonmetals in the case of binary molecular compounds. So this begs the question, which element appears first in the formula or name in the case of a binary molecular compound? Because in the case of binary ionic compounds, it's very simple. It's a metal first, then a nonmetal, right? But in the case of binary molecular compounds where you have two nonmetals, which one comes first? And the answer is that the one that is less electronegative would come first. And going back to the table, find it. There is a chart which gives you the electronegativity values of the different elements. I think it's the last page, if I'm not mistaken. Right, this page right here. So this gives you the different elements and their electronegativity values, right? And we're going to talk about electronegativity later on, but you should have met it before in your introductory high school chemistry. And basically, if you have two elements combined, I'm just going to choose two arbitrary elements that are nonmetals. If you have, let's say, silicon and chlorine. Let's say the compound is silicon combined with 4 chlorine atoms, right? That means that the formula would be SiCl4, right? The silicon will come first and then the chlorine after, right? So that's the thing that you're going to use to determine which element comes first in the formula and also in the name. The one that is less electronegative will appear first in the formula. Now, the other thing that you have to be concerned with is how do we actually directly name it? We start off with the first element first, but the second element will have the IDE ending, right? Another thing you have to take into account, and this is one big difference between binary molecular compounds and binary ionic compounds, is that you have to indicate the number of atoms of each element present in the molecular formula, right? How do you do that? Then you have some prefixes you have to use. Write them down here. So some prefix you have to use. You have mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa or hex for 6, hepta, I should say, for, actually hexa is correct. Why correct? Why I changed it? Hepta is 7, octa is 8, nona is 9, and deca is 10, and we're going to stop there. There's some more, but for all purposes, we stop at 10, all right? So you have to use these prefixes also when it comes to naming these compounds. And let me just say that while that is true, there are some exceptions, and I'm going to get into those exceptions shortly, right? So let's say, clear this here. So let's say you're given, I'm trying to think of a good example. Let's say you're given, okay, I think I did this one in the videos, N2O3, all right? And let's say that's the formula you're given, and you're asked to name this compound, right? So this is how you go about naming it. Because you have 2 nitrogens here, you have to indicate that there are 2 nitrogen atoms. So the first part will be dinitrogen, all right? And then because you have 3 oxygens, you have to put tri, but instead of oxygen, as I said before, the ending of the second element must end with IDE, so therefore it would be trioxide. And that would be the name of this compound. So the name of this compound would be dinitrogen trioxide. All right? So if I gave you this, what do you think the name of this compound is? Start off with the first part. How would you name that part?
Phosphorus.
Diphosphorus. Okay, and then
Pentaoxide.
pentaoxide. And let me just say, since you said that, let me just say something, write this down. Pentaoxide. Let me just say that according to IUPAC, you can also say pentoxide, right? And I'm actually seeing both in different chemical literature, right? So if you say pentaoxide or just simply say pentoxide, both are just as correct, all right? Okay, now let me just talk about a couple of exceptions to the rules that I just mentioned. One of them is the fact that if you have only one atom represented for the first element, right? So you have the formula, there's only one atom present for the first element, not the second one, right? Then according to IUPAC, you do not use mono, right? For that element. So for example, if I gave you PCl5, right? You'd be tempted, if you did not know the exception, to say, well, you start off with monophosphorus. That is not correct, right? So this here would not be correct. The mono part would not be correct, right? Because for the first element, there's only one atom. Now, if you have two or more, then you have to use di, tri, whatever, right? But if there's only one for the first element, no mono prefix is used. But for the second element, you have 5 chlorines, right? So this would be pentachloride, right? So the correct name for this compound is phosphorus pentachloride, all right? So that's one exception to all the rules that we just discussed, right? If the first element has only one atom, then we do not use any prefixes for that first element. Okay, the other exceptions are compounds that are binary molecular, but one of the elements is hydrogen, right? So like, for example, this compound here, HCl, right? According to the rules, IUPAC rules, in this case, no prefixes are used whatsoever, right? So the name of this compound would be hydrogen chloride, right? And not monohydrogen monochloride or hydrogen monochloride. It's just simply hydrogen chloride, right? So this exception deals with situations where you have two elements that are non-metallic, but one of them is hydrogen, right? If that's the case, there are no prefixes used at all. Let me give another example. Suppose you're given this, right? H2S, right? The name of this compound is simply hydrogen sulfide and not dihydrogen sulfide. Just simply hydrogen sulfide. Again, no prefixes used, right? So those are the rules when it comes to naming binary molecular compounds, all right? So just to briefly recap, the less electronegative element will be first, followed by the more electronegative element. You have to use prefixes in most cases, right? And I gave you the list of prefixes a while ago. And the second element always end with IDE, right? And also the exceptions, right? If the first element in the formula has only one atom, then no prefixes are used. And then in the case of binary compounds containing hydrogen, no prefixes are used in those situations at all. So let me get to the assignment. Where is it? Okay, so let's start off with number 1. It says, when writing the name or formulas for binary covalent compounds, the rule is that you write the non-metal with the more metallic character, which is the same thing as I said before, the one with the lower, what do you call it, electronegativity value, right? So it says, which of the non-metals would you write first? And the first one is oxygen or nitrogen. So you'd have to refer to that table that I showed you earlier. So which one is less electronegative? Is it oxygen or is it nitrogen? The nitrogen. So the answer for this one would be the nitrogen. So I will just circle that one, all right? What about iodine and chlorine? Which one would you mention or write in the formula first? In other words, which one is less electronegative? Excuse me. Which one is less electronegative? No, B.
Oh,
Between these two, iodine and chlorine, which one is less electronegative? Iodine. Exactly. Okay, what about C, silicon or sulfur? Which one is less electronegative? That table, the electronegativity value table. The very last one in that document that I've provided in Canvas. All right, let me see if I can bring it up here. Okay, here's the table. So we're looking at silicon and sulfur. So which one would have a lower value? Silicon or sulfur, which one would be first? Steering right at you right here. Which one has a lower value? Is it the silicon or is it the sulfur? Silicon, exactly. So let me go back here and circle this silicon. Okay, so silicon. Okay, the next question is, why is it necessary to use prefixes in the names of covalent compounds? And the answer is what? Why is it that we use prefixes to indicate what? To indicate how many atoms of the different elements present in the molecule. Exactly. So that's all you have to write down to answer that question. Right? The reason why it's necessary to use prefixes in the names of covalent compounds is to indicate the number of atoms of each element present per molecule. Right? Okay, let's see what follows that. Okay, we just talked about this. In what cases do we not use prefixes? Here's here. In what cases do we not use prefixes in the names of covalent compounds? What did I just say a while ago? There are two instances.
one of the elements, hydrogen.
If one of the elements is hydrogen, right? We're talking about binary compounds here. Two elements, so if one of them is hydrogen, no prefix at all, and what's the other case? The second case. Hmm? No, we're talking about metals and metals. I mean, non-metals and non-metals. That's basically what we're talking about, covalent compounds. So he just mentioned that if one of the two elements is hydrogen, then we do not use prefixes at all. And that is true, right? But there's another situation where we do not use prefixes. And that is what? In the case of binary molecular compounds.
First element.
If the first element
One atom.
has only one atom, then we do not use any prefixes for that element, right? So those are the only two instances when it comes to binary molecular compounds that we do not use prefixes, right? Okay, let me scroll down here to see what's up next. Okay, so now you're gonna get a chance to determine the formula based on the name and the name based on the formula. All right, let me help you out with a couple of these. Let's look at the first one. They gave you the name as iodine heptabromide. So what do you think the formula is? Let me turn on the page here. Okay, so that's the name. What's the formula? Iodine, what's the formula for the iodine? Well, what's the formula for the iodine? Folks, this is not too hard. What's the formula for iodine? You can look it up in the tables. All right, okay, very good. And then it says here heptabromide. So you know that the second element is bromine, right? And the formula would be Br. But what does hepta mean? 7. So therefore, that's the formula, IBr7. All right? What about the next one? Dinitrogen, well, firstly, any question about the first one? Any question about the first one? Okay, what about the second one? Dinitrogen pentoxide. What's the formula for that? Dinitrogen pentoxide. Well, dinitrogen pentoxide. What's the first part of the formula? N2, and then O5, exactly, and that's it, all right? So, if you understood what we just did for the first two, you should be able to do the others. Let me scroll down here because the other part is the reverse. They gave you the formulas and they're asking for the name. So let's do a couple of these. Let me just clear this here. Okay, starting with this one, SO3. So that's a formula. So what's the name? SO3, what's the name of it? Based on the rules. Sulfur, what? Trioxide, very good. Sulfur trioxide. What about the next one? XeCl4. XeCl4. And by the way, you guys out there in Zoom, you can chip in as well. So what's the name of XCCL4? What's the name of the first element represented by Xe? Xenon. And then how do we deal with the second part, the CL4? How do we name that part? Tetrachloride, exactly. Tetrachloride. That's what you said, right? All right, so tetra, of course, because there are four chlorines, and then they all end with IDE. That's another important thing you need to remember. All the names of these binary molecular compounds end with IDE, right? Okay, so based on that, you should be able to complete this section here. So let me allow you to do that. Check what's. Oh, and you should be able to do, yeah, you should be able to do these as well. So in addition to what you see here in the chart, or in the table, let me clear this here. So in addition to what we just looked at in the table, you should also be able to do this section here where it says write the formulas for the covalent compounds and write the names. So all of this you should be able to do. So I'm going to leave you to do that. Let me see part B. Okay, we haven't dealt with acids yet. All right, so I'm going to allow you to, I'm going to end it for today. So what I want you guys to do is to attempt this table here and this here where it says write the formulas for the following compounds, and then here where it says write the names of the compounds. And then what I'm going to do is we're going to look at how we name acids next class. All right? Okay, so that's pretty much it. Let me remind you, of course, that your test is available now in the testing centers. Doesn't matter which one you go to, Citrus, Ocala, or Levy. Please look for, at the top of the page, spring 2025, right? Because I've had some issues with them last semester, where they gave my students some past tests. So look for spring 2025. If they give you, if they give you a test and it doesn't have that, then let them know, right? And you have until Friday to do it, so I can grade it over the weekend. Hopefully I can get it back to you next week, all right? Yes, ma'am.
So when we like submit our assignment, if that part isn't like completed, okay?
No, you're not submitting it yet. You mean this assignment?
Uh-huh.
Right, you're not submitting it yet because we have to do the acid part first.
Okay,
And then you'll be able to submit it after.
so after next.
Yeah. Mhm. Yes,
Not do this Friday, let's do next Friday.
you mean this assignment?
Yeah,
Yeah, it's not going to be due this Friday because we haven't finished it yet,
okay.
all right? Okay, so that's it, folks. See you guys next week and wish you all the best for your test. Should have no problem with it. I mean, if you review
The test is chapter 20.
chapters 1 and 2, I don't think I've included 3 in it, so you should be all right, 1 and 2, right? And if there's any issues with the testing center, please email me ASAP so I can deal with it immediately. Oh, take care.
Sorry.
Yeah, no problem.
So I think it was like chapter 3 assignment. I didn't realize that it shut, but I we had like an entire week to do it. So I emailed it to you and because I couldn't like submit it to.
Oh, okay.
this. And then the other one, I had emailed you about because the PDF didn't upload all 5 pages, it only
Oh.
uploaded the first one.
Okay,
But my grade didn't usually come in, so,
So, but you emailed it to me, right?
yeah.
Okay, I'll get to it.
Alrighty,
Does that happen? No, I'm tweaking.
thank you.
What's your name?
Courtney, here to speak.
Okay, all right. Yes, sir. Yeah.
I know it's been forever and it's my fault, but I didn't get to turn in assignment 2, 3, and 4. I've had a lot of family problems right now. My dad got deported.
Oh, okay.
So, it's been bad.
Hmm.
And I don't know if I can get an extension.
Well, what you can do is email me those assignments, make sure it's in a PDF, format,
Yeah.
when you email it to me, and then I'll just grade it and into the grading system.
Yes, okay, I appreciate it very much.
Yeah, no
I just
problem.
have a lot.
Okay, all right, no problem.
Also, the exam, or what is it, the test?
Yeah.
I go into CF. And I put CF classes in here, or how do I do?
You have to go, I'm not sure the website
Yeah,
is,
the
but,
website, it says CF classes in, or like the CF testing center.
yeah, exactly, and you have to set up an appointment. But, I think the system, I know that you cannot have the exam, or you cannot do the test too late.
Okay.
Because I think they said that you have to at least be there like 2 hours before closing time or something like.
Is it on paper
It's on paper, yeah. Yeah, it's pretty much, similar to what we did in class,
or? Okay.
in terms of the assignment. Right?
All right, thanks, I appreciate it.
Yeah, no problem.